Hello there and welcome to the revision video looking to answer question 2 from revision sheet 1. Let's get started. So I have a complex number here, alpha, which is 5 plus 2i, and I'm asked to compute alpha over alpha star plus alpha. So it looks like to start with I have the division of two complex numbers, alpha, and I know alpha, that's 5 plus 2i, and divide that by alpha star. Now what alpha star here refers to is the complex conjugate of alpha. And the way I work out complex conjugates is to change the sign in between the real part of your complex number and the imaginary part of your complex number. In this case it's a positive, so I need to change that to a negative. If it were a negative, I would change it back to a positive. But now I need to simplify this. I've got I on the bottom of a fraction, which I don't really like. It makes it complicated to add together with that alpha at the end. So I need to effectively rationalise or get rid of the i's on the bottom of my fraction. And the way I do this is timesing by the complex conjugate again of 5 minus 2i. So minus will change to a positive. And so that I don't change my complex number, I need to times by 5 plus 2i on the top as well. So what I've got here, timesing the tops of my fractions together, I have 5 plus 2i times 5 plus 2i, and on the bottom I'll have 5 minus 2i times 5 plus 2i. And now I need to simplify this by expanding the bracket, making sure that I times every component in the left-hand bracket by everything in the right-hand bracket. So 5 times 5, that makes 25. 5 times 2i, that makes 10i. Moving on to the second bit, 2i times 5, that makes 10i. And 2i times 2i, that makes plus 4i squared. And I'll simplify that later. On the new denominator, 5 times 5, that is 25 again. 5 times 2i, that makes 10i. Minus 2i times 5, that's minus 10i. And minus 2i times 2i makes minus 4i squared. So let's go ahead and simplify what we've got here. We know that I squared is minus 1. That comes straight from the definition of I, which is the square root of minus 1. So here I've got 4 plus 4 times minus 1, which will make a minus 4 in total. And I can simplify that together with 25. 25 take away 4 is 21. And add together my imaginary components, I get 20i. And on the denominator, I can see that my 10i and my minus 10i cancel each other out, just as I expected. And here, a little bit more complicated, I squared being minus 1 needs to times by minus 4, so that's the double negative happening there, that will make positive 4. So 25 add 4 gives me 29 on my denominator, and I can also split this up, 21 over 29, add 20 over 29i. So that's the answer to the first bit. And now I've just got to finish the question off by adding on alpha. So my answer is going to equal 21 over 29, add 20 over 29i, and add on alpha. I know what alpha is, that was my initial complex number, 5 plus 2i. Now I'll just get my calculator out and simplify 21 by adding the real parts and the imaginary parts together. So 21 over 29, add 5, gives me 166 over 29. And the imaginary parts, adding 20 over 29 with 2, gives me 78 over 29i. And that's the answer to question 2, 3 marks.